Next chapter that we are going to see the systems of classification. The systems of classification that we are going to see. Classification of heterogeneous group of angiosperms that become very interesting and challenging for the taxonomist. Interesting in the sense that to classify the plant, to separate the plant, this is interesting, and challenging in the sense that there is a challenge to identify, to classify and to give the name to the plant. So the varieties of the plants are there. Lot of plants that we used to see in the entire universe, right from the algae, fungi, bryophyte, pteridophyte, gymnosperm, angiosperm. So we will concentrate on the angiosperm only. I would like to tell you that more than 250,000 of angiosperms are there that is in the universe. Now these 250,000 of angiosperms, that is the flowering plants, these flowering plants that we should have to classify. The particular attempt that has been made by the help of the scientists time to time, they have classified all plants. They have classified the algae, they have classified the fungi also, and they have classified the flowering plant especially, that is the angiosperm. Now this angiosperm that may have been classified as far as the briefly they have been classified as the dicot, monocot, polypetally, gammapetally, whatever it may be. But this attempt or the effort that has been taken by the help of the scientists time to time, which was very challenging, because at that time the particular type of the invention, particular type of the discovery was not there, particular type of the apparatus or the equipment to be utilized for the classification were not there, and that is why whatever the effort that have been taken, that has been creditable. So this becomes challengeable, or this becomes the challenging as well as the interesting answer. Now the classification, that is nothing but this separation of the particular type of the plant. Now according to the primitive man, according to the use, the primitive man have been tried to classify the plant on the basis of food as well as the medicinal point of view. Now according to this medicinal and the food value, thus the classification of the flowering plant originates. The main object of the classification is put the plant into the convenient group. To put the plant into the convenient group, so that it will possible to separate the plant, what type of the groups are there. This is dicot group, this is monocot group, or this is the petals which are the free, petals which are united. These are the convenient group, and these convenient group, this is the main object of the classification as such concern. So right from beginning in the 15th century, the particular effort that has been taken by the help of the scientists, different methods of the classifications were there. Different methods of the classification of the plants were there. The first method, that is artificial system. Artificial system. Second, that is natural system. And third one, that is the phylogenetic systems. The three systems were utilized to classify the entire plant, especially the flowering plant as such concerned. So let us see that the artificial system as first. Now this artificial system, it directly indicates that it is artificial. It means that whatever the easily and readily available character that was taken into account. So readily available character. So whatever we go in the internal forest or we go in the field, then we will collect the plant, and that plant are having the gamma-petalous corolla, that plants are having the reticulate venation, that leaves are with the reticulate venation, their roots are taproot system, whatever it may be. So these plants that we have been described, and after description of the plant, we are going to classify the plant as such. Now let us see that whenever the artificial system concerned, the readily and the available character was taken into account. It means that the natural affinity which was not a point to be taken into an account. The natural affinity or natural similarities or the dissimilarities was not a point to take into consideration as far as the artificial system concerned. So what is the main object? The principle, as far as the principle or the object concerned, the main object or the main principle of this system, the artificial system concerned, what are the morphological characters? The morphological character. What is the morphology? The external characters. The external characters may be the flower character, may be the vegetative character. What type of habitat is there? What type of root system is there? What type of the stem is there? What is the stem? What is the leaf? What type of venation? What is the phyllotaxy? These are all morphological characters. Because the morphological characters that we used to see very easily, and by in the first glance of vision that we used to see the plant. And whenever we observe the plant, at that time, we used to see only the morphological character. This is readily available character. This is easily available character. And we are not interested to go in deep, because at that time, before 300 BC, at that time, the particular type of the equipment or the particular type of the apparatus to be utilized for the classification which was not possible or which was not present at that time. And that is why the scientist that has been taken the keen interest, what type of the morphological character is there? What type of the easily character is there? What type of the readily available character is there? And this readily and easily available character was a point to be taken into an account as far as the artificial system concerned. The most of credit goes to this artificial system, that is the Theophrastus, then Aristotle also, Linnaeus also. But according to this system, the Linnaean systems of classification, which is the best example of this artificial systems of plant classification as such concerned. Now the Linnaeus has been taken the more effort. Carl Linnaeus, the father of botany, Linnaeus has been taken the more effort, and he classified the plant on the basis of stamen and carpel. He classified the plant. He has taken the two parameters only. What is that? That is the carpel and the stamens. Now the carpel and the stamen, that is easily possible. The when we used to take the flower, okay, these are the petals, these are the sepals, then take the flower, take the and stamen, take the gynoecium, or take the carpels. How many carpels are there? How they are? How many stamens are there? How they are? And this directly indicates that this is the sexual system of the entire classification. On the basis of carpels and the stamen, he has classified the 24 classes. In this sexual system of plant classification, he published a book, that is the Species Plantarum and Genera Plantarum, in 1729. He described the 935 genera, arranged them together. His artificial sexual system of classification is mainly based on the morphological arrangement. How the morphological arrangement? The morphological arrangement of the entire stamen. How they are? How the filament attached to the stamen. It is the dorsal picture, basic picture, versatile. How many stamen, antherlobe is there? Or what is the position of the entire dehiscent pattern is there? These are all points that have been taken regarding this stamen, and these directly indicate that this is the sexual system of the entire that artificial system. This system was the last among the purely artificial system, with the significance of the floral part. The flower structure was adapted to primary base of the classification of the Linnaean system. Floral part, or the flower characters, flower structure which has been taken into an account. Flower structure was adapted. The flower structure was adapted at the primary base. Flower structure, how the flower is there. Flower structure, whether it is actinomorphic or zygomorphic. Actinomorphic means when we try to cut the flower, and if it will give rise to the two equal half in one plane, at that time it is actinomorphic. If it is not given rise to two half in one plane, it directly indicates that this is zygomorphic. Means zygomorphic flower, actinomorphic flower, bisexual or unisexual. Whether presence of the both sex organs, that is androecium and gynoecium, which are present within them, if that is called as bisexual flower. If it is not there, one of them is not there, that is unisexual flower. It means that the floral characters or the floral parts or the floral structure which was taken into an account, but these floral structures that directly indicate that this is easily and readily available character as far as Linnaean system of plant classification concerned. The merits of these artificial systems. Merits. त्याचे फायदे काय? What are the merits of the classification system? Identification is made easy. Absolutely. Identification is made easy because whatever they enter the readily available character is there that we can directly identify them. So this is the best and important merit concern. Poorly known plants are placed in one of the classes. Poorly known plant. If the plant is not having the particular type of the character, but the characters are present within them, this character does not fit to the total the type specimen. It means that it is the poor plant. So the poorly known plants are kept in the one of the classes. The limitations is also there. This is the merits and limitations. That is the demerit. As far as the limitation concerned, plant having the phylogenetic similarities are placed in different groups. Plant having the phylogenetic similarities are kept in different groups. Phylogenetic similarities, what is that? The phylogenetic similarities, it means that the phylogenetic plant classification, that these plants have been originated from another plant. It means that the evolutionary descent that has been adopted. It means that the evolutionary sequence that has become adopted. And if the evolutionary sequence is not considered in this type of artificial systems of plant classification, no problems regarding the keeping the particular type of the plant in this artificial system. So that the plants were phylogenetic similarities, whatever the plant which were having the similarities as far as the phylogenetic system concerned, are kept placed in the different type of group. It gives the second limitation it gives. The second limitation, it gives the limited information about the plant member. Limited information about the plant member. Okay, no problem. Because at that time, whatever they entered the invention or whatever they entered the disciplines of the entered that biological science was not evolved. Molecular biology was not evolved. Cell biology was not evolved up to such an extent. Palynology was not evolved, which is the one more disciples of the entered biological science. Such a type of the entered the branches of the botany which was not evolved at that time. At that time, only the morphological character, only the easily available character was taken into account. So no problems, and this may become the one more limitations regarding the entire Linnaean systems of plant classification. This system has a little or no predictive value. It is right. Very little value is there, or no predictive value is there. This is regarding the artificial systems of plant classification. Second that we are going to see, second system that we are going to see, natural system. Natural systems directly indicate that. As the name indicates, natural. It means that whatever the natural affinities were there, that was taken into account. Natural similarities were there, that was taken into account. Natural characteristics were there, that was taken into account. So what type of the plants are there which are having natural similarities? The most important or the most important principle behind it, or behind the such type of the system, that is the natural affinities or similarities and the dissimilarities was the basic principle of this system. Natural similarities, whatever the plants are there, for example, the solanum plant or solanum genera has such concern, solanum genus has such concern. For example, I will give rise to two examples: solanum melangena and solanum surutensis. Solanum melangena, this is the regular brinjal, and the solanum surutensis, that is the wild brinjal, has such concern. Both are the same, genus are the same, but we have separated the plant. Natural affinities was taken into account. As far as the natural similarities, natural affinities, what is the natural affinities? Presence of the spines on the leaves, persistent calyx. The calyx remains as it is even after the fruit formation. So such type of the character, the numerical characters, the numerical taxonomy, what we used to see, numerical characters which are taken into account, and they kept this genus into the entire solanum, this plant into the solanum. But whatever the dissimilarities are there, what type of the dissimilarities? The species differ, species become different. When the species raise out, at that time, the dissimilarities are the entire whatever the differentiating character, these differentiating character does not fit to the type specimens of the particular type of the character. For example, the Solanum melangeal as per as the type specimen concerned, and the Solanum surtensis that we found, these Solanum surtensis does not fit to the Solanum melangela because of particular type of the character. One more character that we used to see, huge spines. Lot of spines are there on the leaves, and the habit concern the prostrate habit. Not only these two, but another type of the characters are also there. These characters that can give rise the information regarding this plant, this type specimen does not fit to the enter the Solanum melangela, so that the new species arise. When new species arise, new species is erect out, at that time the dissimilarities are taken into account. So in the natural system, the similarities as well as the dissimilarities which are taken into account, and these points that can directly give the idea regarding the natural systems of the plant classification. Most of credit goes to the entire these acids and decandles. The acids and decandles, they have been classified the plant as per the classified the plant on the basis of the similarities and the dissimilarities of the entire the plant. But in the half century, in the second half century, especially in the 18th century, second half of the 18th century, the British botanist that is called as that is known as Bentham-Hooker, John Bentham and J.D. Hooker, that may have been given the more emphasis on the entire systems of classification, basically the natural system of classification. And this natural system of classification, they have been given one more book, they have published one more book, the Genera Plantarum in between 1862 to 1885. Their systems of classification was based on the digases and the decandle systems of plant classification. Because the digases and the decandle that have been taken the point as far as the natural affinities and natural similarities which are present within the entire group. Now in the Bentham and Hooker systems of plant classification concern, the George Bentham and this is the example of this natural system, Bentham and Hooker. Bentham and Hooker, both were the British botanists, both were associated with the Royal Botanic Garden, Kew, England. They worked together and published a valuable contribution in 3 volumes. That is the Genera Plantarum in between the 1862 to 1883. They proposed the most popular natural system of classification, which was based on an improvement over the decandles and digastric systems of plant classification. They have improved. The digastric and decandle systems which were totally based on the entire natural affinities as well as the similarities and dissimilarities of the entire plant. But they improved, Bentham and Hooker improved the digastric and decandle systems of plant classification. They give the natural system of classification of only flowering plant. They give the only flowering plant. And this flowering plant in the Genera Plantarum, they gave the name, description as well as the classification of 97,205 species of seed plant which were arranged according to the Bentham and Hooker system, belonging to the 7,569 genera, distributed among the 207 natural order. The every genus of these systems, all these species belonging to this system, known at that time was described. The system seems to be basically the natural. Bentham and Hooker seem to be the artificial and natural as far as the higher measure taxon concerned. The system seems to be artificial and natural as far as the higher measure taxon concerned. But it is more the system seems to be phylogenetic and natural as far as the higher measure taxon concerned. But it is more artificial than natural and phylogenetic because closely allied families or the closely allied plants are kept in widely separated groups. The systems seems to be the natural, or system seems to be what we used to say, seem to be phylogenetic and natural. System seems to be phylogenetic and natural. It means that the phylogenetic concern, this phylogenetic system that can give the idea regarding the evolutionary sequence. So that this Bentham-Hooker system seems to be phylogenetic as well as natural. Natural, why natural? Because of the particular type of the plant was classified, particular type of the plant was kept in the group on the basis of natural affinities as well as the natural similarities as well as the dissimilarities of the particular type of the plant as such concern. But this system is similar, seems to be more phylogenetic and natural as far as the higher major taxon concerned. But it is more artificial than natural because closely allied plants are kept in widely separated groups. Closely allied plants. It means that the plants which are so same are kept in widely separated groups. This is the so-called as one more basic principle or the basic point which are taken into account as far as the particular type of natural system of plant classification concerned. All these seed plants were divided by them into the three classes, that is the dicotyledon, gymnosperms and angiosperm. Gymnosperm and monocarp. And the class were divided into subclasses, that is the polypetally, gamopetally and monoclamidy. The gymnosperm was not subdivided into the subclasses and series, but are directly divided into the directly divided in natural order and families. The class monocot was divided into the 8 series. Thus, all the seed plants were divided into the 3 classes, 3 subclasses, 21 series, 25 orders, and 202 families by Bentham-Hooker systems classification. Now, you will have to do, in the book there is a chart of the entire Bentham-Hooker systems of plant classification. You will have to sketch that chart on the entire large size paper. You can do it. That is the phanerogams is divided into the class, that is the dicot and monodicot and monocot. In between dicot and monocot there is the gymnosperm, that is by the Bentham-Hooker system. The class dicot is divided into the polypetally, gamopetally and monoclamidy, and monocot is divided into the 8 series, and this polypetally is divided into the particular type of the orders, then families, and then genus. So there are the 8 families that we have been studied by the Bentham-Hooker systems of plant classification. Now, the merits and limitations of Bentham-Hooker systems. Merits of Bentham-Hooker systems of plant classification. The first merit is that the system has the simple megascopic characters of the flower, so become natural system, therefore easy to follow and good for the field work. It means that the megascopic characters are there. We can see the plant by natural way. We can see the plant in the first class of vision. In the field that we used to go in the field, that we take the plant and we can see. That is the megascopic character. Flower, for example. We can see by naked eye. The flower, petal. If you are very aware of what is the petal, what is sepal, what is calyx, what is corolla, what is androecium, what is gynoecium. If we are aware with these all botanical terms, it is possible to see that it is possible to identify the plant. It is possible to describe the plant. Whenever the polypetalous, the petals are free. Whenever the gamopetalous are there, petals are united. How many stamens are there? We can count it. How many carpels are there? We can see. So by the megascopic character, it is easy to follow as far as the practical purpose or as far as what we used to see as a field purpose, field work also. Second, that is placing of ranel is reasonable because order has a primitive position in dicot. Placing of ranels is reasonable. Placing of ranels in the Bentham-Hooker system is first. Because this ranel should be first and it is reasonable as far as the primitive, as far as the entire evolution is concerned. The primitive position, it means that the ranels has been kept in the first because members of the entire order ranels, for example, the entire members of the order ranels or the family of the ranels is Anoniaceae and Magnoliaceae. These Magnolia champaka, that is the living genus or living plant, whatever they entered, the fossil plants were there, that is in the entered that ranels order. So ranels order has the fossil evidences, that should be in the first. these placing of ranels in the first step, or in the firstly, as far as the primitiveness concerned, which was reasonable. Second, that is disciplinary is placed in between the thallamiceflory and calciflory. As far as the evolution point of view, as far as the modification point of view, it is reasonable. Monocot is placed after dicot. It is right. As far as the monocot is evolved from the end of the dicot, as far as the evolution point of view concerned. Placing of gamma-petalae after polypetalae is justified since the union of petal is concerned to be advanced over the pre-petal condition. Yes, this is right. Union, that is very important. The union that is very important, whenever the natural calamities is there, whenever natural disaster is there, at that time, if the petals are free, if the flowers with the free petals are there, at that time it is a possibility arise to destroy the plant by the help of the natural calamities. Okay, no problem. So, the placing of gamma-petalae after polypetalae, it means that the polypetalae was primitive and gamma-petalae become advanced. It means that the protection that has been given by the help of the entire innermost organ, especially the essential growth, that is calyx and so what is that androecium and gynoecium. These androecium and gynoeciums are the essential growth, and this essential growth that should be protected by the help of the entire petal and the sepal. So the union of the petal and the union of the petal and the sepal become advanced condition. This advanced condition over primitive condition, that is the polypetalae, this is justified. This is correct. As far as the union of the petal, this become advanced over the free petal condition is there. Next merits is that various genera grouped under the family and different families are grouped under the order were based on overall similarities and differences among the plant. Various genera grouped under families. Various genera. For example, Solanacea family is there. In the family, varieties of the entire genera are there. For example, the Solanum, Vidania, then the Atropa, then the Datura, then the Sistrum. These are the genera. Capsicum, these are the genera. Then Lycopersicum, these are the genera. These genera, various genera are kept in the entire family, and different families are kept in the order. These are all families, for example, the Solanaceae and Apocynaceae. These Solanaceae and Apocynaceae are kept in the entire order Polymonium because they are having the persistent calyx or the entire gamma-petalous calyx or the bicarpellate order. These bicarpellate orders will directly indicate that the total the carpels are 2 bicarpellary ovary there. It means that whatever they enter the character belonging to the entire gynoecium, which are same belonging to the various family, that family has been kept in the entire order. So this directly indicates that these various genera are grouped under the family and different families are grouped under the order were based on the overall similarities. The similarities which was taken into an account because similarities and the differentiating character are differences which are the basic principle of the natural system done by the help of the decandoles and the disaster systems of plant classification. And this Bentham-Hooker system which is the improved, they have improved the decandole and disaster systems of plant classification as concerned. It means that these are all points which are taken into account is that the similarities as well as the differences among the plants. These are the all merits or the advantages are there. But over these, however, the entire these advantages are also there. At that time, some limitations is also. These limitations that we are going to see belonging to the Bentham-Hooker system. Limitation. This limitation, the system does not give any idea. First limitation, system does not give any idea about the phylogeny of the flowering plant. It is based on the artificial system. Just we have been seeing. It does not give any idea regarding the entire phylogeneity. Because the Bentham-Hooker system, this type of the system are totally based on the entire character, that is the dissimilarities and the differences among the plant. Not evolutionary sequence that was taken into account. Not any type of the evolution descent, they are not focused on the evolution point of view. it means that this is the drawback of this system. The placing of gymnosperm is second, that is placing of gymnosperm in between dicot and monocot is the greatest drawback of this system. Basically, gymnosperm, then dicot and then monocot as per as the polybotanical evidences should be there. Because gymnosperm, which are the vesselless plants are there. Here the flower is not present within them. These are not a flowering plant, gymnosperm. Actually, the gymnosperm, then dicot and then monocot. As far as the paleobotanical evidence concerned, this should be like this. But they have been kept in between the dicot and monocot. They are gymnosperm in between them. This is the greatest drawback. The third limitation. System seems sometimes look as artificial because closely related plants were kept in widely separated group. Yes, systems seems to be artificial because closely allied plants are kept in widely separated group. Even, for example, the separation of polypetally and apopetally by gamopetally is not correct. Separation of polypetally and gamopetally is not correct. Apopetally means petals are not there. If the petals are not there, that comes under the apopetally. If the petals are free, that is the polypetally. And the polypetally, separation of polypetally and apopetally by gamopetally, it is not correct. Because gamopetally, the petals are united. And as far as the limitation concerned, this is right. Then another limitation that we are going to see. Classification of monoclamady has become artificial due to the random choice of characters such as number and size of the seed. Classification of monoclamady has become artificial. Monoclamady are the third group of the internet plants as far as the polypetally, gamopetally and monoclamady. The classification of monoclamady has become artificial due to the random choice of the character as far as the number and size of seed concerned. Number and the size of seed which are not used does not become the character to identify the plant, to classify the plant. It depends upon the environmental condition. If the environmental condition is sufficient, if the environmental condition is moderate, at that time the size of the seed become more, number of the seed become more. For example, groundnut plant is there. For example, groundnut plant.